Hey everyone, so now that we know how to solve equations with integers, meaning positive and negative whole numbers, and we know how to solve equations with fractions, today we're going to focus on solving equations with decimals. So this is going to be the equation that we want to solve today. Negative 9 minus 2 times the difference of 3.2x and 9 plus 2x equals negative 4.9x. So what we need to remember is when solving equations with decimals, use the same steps you would use when solving equations with integers. So hopefully you remember that kind of corny, don't call me after midnight. Let's make sure that looks like a C. To help you when we're solving these. So we always distribute first, then we combine like terms as long as they're on the same side of the equal sign. Then we move our constant, we add or subtract, and then we multiply or divide in the end. So one extra thing that you should have is have a calculator handy to help you out. It might be a while since you've worked with decimals, and it can be a little easier when you have that calculator handy to help you out with either multiplying or dividing them. Hopefully addition and subtraction shouldn't be too tough. But yeah, I would have a calculator handy. So we're going to start by drawing our train tracks. Let me make sure. Okay. And like we said before, the first step is distribution. So we see parentheses. Remember, we're going to distribute whatever is right outside that set of parentheses to what's inside. Notice that I'm circling that negative 2. I'm circling that negative sign with it, that subtraction sign, because we're going to treat it like a negative 2. So negative 2 times 3.2 is negative 6.4x. Negative 2 times negative 9 is a positive 18. Now, anything else we didn't use, we're going to just bring down. So that 9, that plus 2x, that equals negative 4.9x as well. Okay, so we distributed. Now the next thing that we want to do is combine our like terms. So here we know on this side of the equal sign, this negative 4.9 doesn't have any like terms. So we're not even going to look at this side. We're only going to focus on this side. So I'm going to go ahead and identify some like terms here. So we have negative 9, which is like terms with this positive 18 because they both do not have a variable. So I'm going to combine those first. Negative 9 plus 18 gives us a positive 9. Now the second set is this negative 6.4x and this plus 2x. They both have that variable x, so we know they're like terms. And when we combine those, we get negative 4.4x. Remember, don't go across the equal sign here. We only combine like terms if they're on the same side of the equal sign. Okay, now we're going to solve. It's a two-step equation now. So the first thing we want to do, so we did our combining like terms. The next thing we want to do is move our constant. So let's see, would that help us out? If I move this 9 over here, it's not like terms with this negative 4.9x. So I'm going to skip that step. So add or subtract. So I'm going to add this 4.4x to this side because I want to get this away from the 9. So we have the variable on one side and the constant on the other. So I'm going to add that 4.4x using those inverse operations that we talked about before. Okay, so these cancel and I'm going to bring down that 9. And when we add those, we're going to get negative 0.5x. Negative 0.5x. Okay. Lastly, we want to divide. So let's divide by that negative 0.5 to get it away from our variable. So that cancels here. And when we divide, 9 divided by negative 0.5 actually gives us a negative 18. Kind of weird, but if you remember decimals, that's how decimals work. Okay, so our answer here is negative 18. All right, I just want to make sure that that doesn't look like a plus sign. It is definitely a negative number. Okay, let's take a look at one more. Okay, so we have -1 plus 8 times the sum of -1.3x plus 1 equals 1 plus 2 times the sum of -4.4x and 2. So let's start with our train tracks. And that first step is distribution. We have parentheses on both sides, so I'm going to distribute at the same time. Okay, so 8 times -1.3 is -10.4. And don't forget the x. Then 8 times 1 is just 8, because anything times 1 is itself. And I'm going to bring down that -1 in front. Don't forget that. Okay, I'm also going to bring down this 1 right here, and then I'm going to distribute. So we have +2 times -4.4 gives us a -8.8x. And then 2 times 2, they're both positive, so that's going to give us a +4. Okay, so now we're going to look at both sides of the equal sign, and we're going to combine like terms if possible. So on this side of the equal sign, we have this -1, and we have this +8. They're like terms because they both don't have a variable. So -1 plus 8 gives us 7. And then I'm going to just bring down that -10.4x. Equals. Now on this side, we have this +1 and this +4. They both don't have variables, they're both constants, so we're going to combine those and get 5. And then we're going to just bring down that -8.8x. I just want to clean this up a little over here. Don't really like the way that looks. Okay. Now we're going to start moving things around. So we're going to move the variable with the smaller coefficient. So if you remember negative numbers, really the bigger the negative number, the smaller it actually is. So I'm going to move this 10.4x. Remember, that's just a suggestion. You don't always need to start that way. And we're going to add that to whatever it's like terms with. These cancel out over here. I'm going to bring down the 7. I get 7 equals 5. And then when I add those together, I'm going to get positive 1.6x. Okay, let's go ahead and subtract that 5 now, because we want to get that variable by itself. So we're going to get 2 equals 1.6x. And our last step here is to divide that 1.6 on both sides. So we have that variable isolated. And when we divide 2 divided by 1.6, we get 1.25. So 1.25 equals x. Make sure you can see that decimal there. And it disappeared. Okay. And that's it. So exactly how we would solve it if it was integers. So remember to distribute first, then combine like terms. Then you're going to move your variable with the smaller coefficient, if applicable. And then you're going to just use inverse operations. So we moved our constant, we subtracted it on both sides, and then we divided in the end to isolate our variable. And that's it.